Welcome to solverfy.
A hypothetical student has drawn 6 different possible structural isomers of the compound C7H16. And this question is asking us how many structural isomers are actually present here. So I've gone ahead and already drawn them out to save time, but I do briefly want to talk about my rationale and how I got these drawings. So for each of them, I started with the root chain, which ends in ane. So for the first one, for A, for propane, I started with a 3-carbon base chain. I then added an additional group in the first position, or the position that corresponds to that number at the beginning. So in the first position, I added a seq butyl group. So that would be right here. And I basically just followed that same process of adding the initial root chain. So that would be this. And then adding a secondary group in the numerical position. So in this case, I added a methyl to the 4th chain, and so on and so forth. Started with a pentane in C, added an ethyl group to the 2nd position. And if you have any questions about what those groups are, what an ethyl group looks like, it is C2CH13, but I pulled those off of table 22.2. So now that we've drawn them, gone through that same process for each of the components, we need to look at what these structural isomers are, or what we've actually represented. And to do that, we're actually going to count the longest root chain of carbons in each case. So for A, when we count the longest continuous chains of carbons, we get 1 here, 2, 3, 4, 5, 6 carbons is the longest continuous chain. So that means it's a hexane. And then if we actually rotate this chain, or like we straighten it out, you'll realize we have a methyl group that is hanging off the 1, 2, 3rd carbon. So number A is actually 3-methylhexane. And if we go to B, it's technically 4-methylhexane, although if you literally turned your screen around, you would also be able to see that this methyl group was off the 3rd compound. So we can actually say that this group is equivalent to 3-methylhexane as well. Because again, we have a root chain of 6 carbons, and then we have a methyl group that is off the 3rd chain. For 2-ethylpentane, again, we can say the longest continuous chain of carbons is 1, 2, 3, 4, 5, 6, with a methyl group off of the 3rd carbon. Starting to notice a pattern. Hexane. I ran out of room, but that's what it is. There we go. And then 1-ethyl, 1-methylbutane. We have 1, 2, 3, 4, 5, 6 carbons with a methyl group off the 1, 2, 3rd. Three-methylhexane, I mean, I don't even have to problem solve for this one. 3-methylhexane is equivalent to 3-methylhexane. And then 4-ethylpentane, we'll do the same process. 1, 2, 3, 4, 5, 6 continuous carbons, and 1 methyl group, which is off the 3rd chain. So this is also 3-methylhexane. So in short, there is 1 structural isomer and it is all 3-methylhexane is really the only structural group that they drew here. And then one isomer.